Hello guys, welcome back to STEM Trainers. Now today we are going to see integration by parts. So let's understand. So sometimes what happens is we have integration of functions which is actually a product of maybe two or more functions. So for example, integration of x sine x, or you have integration of x e power x dx. Now you can see this is product of two functions. So many more examples are there, x ln x dx and many more. So whenever we have two or more functions, so what we use is integration by parts to integrate this. Now what is integration by parts? So integration by parts is basically integration of u dv is nothing but uv minus integration of du into v. So basically in short, we can write this as integration of u dv is nothing but uv minus integration du into v. So this is what we can say simply. So this is basically, you can say, our product rule for integration. Like we have product rule for differentiation. So in the same way, we sometimes call this as product rule for integration. So there are a couple of things that are important in this. First is, now for example, let's take the first question. For example, so if you want to integrate x sine x dx, so the first question that comes to our mind is, what is u, what is dv? So how do we determine what is u, what is v? Is there are two methods for this. Either you can use ilate, or sometimes people just use late, or sometimes they use liate. Both are kind of similar. So I just want to tell you everything so that there is no confusion in case you are studying some book and some method is written there and you don't know what it is. Okay, so ilate, I stands for inverse functions and L stands for logarithmic functions. A stands for algebraic functions. Algebraic is like x, x square, square root of x, rational functions. T stands for trigonometric functions like sine x, cos x, secant x, tan x, etc. E stands for exponential functions like e power x, a power x, 2 power x, 3 power x. So functions like this. Okay, so what we do is we see the order. So for example, first question is x sine x. So we see x is algebraic function and sine x is trigonometric function. So in this, algebraic functions comes before trigonometric functions. So it means whichever comes first, that becomes our function u, and whichever comes later becomes our dv, or you can say v function. So if you have x e power x, so automatically algebraic and exponential, algebraic comes first, so obviously I have to take this as u and this as dv and then apply by parts. In x ln x, logarithmic comes first before algebraic, so it means my ln x will become u and this will become dv. So now this ilate or liate, see both are kind of similar. There are exceptions in both, so nothing is perfect. It's not that these will work 100% of the cases, no, but more than 90-95% of the cases it will work, and for A levels 100% of the cases it will work. So you don't have to, either you can use ilate or liate, no problem. Okay, so we will see some exceptions if time is there, maybe in some other video we will see the exceptional cases also. Okay, so this is all about this. So whenever a product of two or more functions is given and you have to integrate that, we will use by parts, first thing. Second thing is, we should know what is u, what is dv. Okay, so these are the only two things that you need to know. Okay, so let's start the application. First question. Okay, first question is this only, integration of x sine x. So first thing that I do is generally is I write the formula u dv equals uv minus integration du v. It helps me. Okay, second thing is, I know I late. I late, it means a comes before trigonometry. So obviously, first I will write u. What is my u here? U is x. And what is my dv here? dv is sine x. Okay, so these are on the basis of I late. Okay, next thing is, you can see in the formula we will be needing du and we will be needing v. So let's find that also. So du will be 1 only. So basically du is nothing but du by dx. So I'm not writing that because see it is du by dx, but we are writing in short. Okay, so that's why du is 1. So basically it's du by dx. Second thing is integration of dv. That will give me v. So integration of sine x is minus cos x. So whenever I see an integration by parts question, first I write the formula, then I write u, dv, and then I find du and v. Now once I write this, it becomes very easy to apply this. So this integration is equal to u. What is my u? Is x. Now I am seeing the formula and substituting values. V is minus cos x minus integration, then it's du. Du is 1. Very good. And v is minus cos x, so minus cos x, and obviously it's integration, so you have to write dx. Okay, because in original it's dx. Okay, so let's simplify this and see what happens. So this is nothing but minus x cos x. So this minus becomes plus integration of cos x dx, and we can easily integrate cos x. The integration of cos x is sin x. So plus sin x, and because it's indefinite integration, so we will use constant of integration. Let's use c. So this is my answer. So this is my answer for this integration. Now you can see how easy is this. So this becomes easy once you write the formula and then you write the values and you find du and v. Then it's all about substituting the values. You will get the answer very easily. Okay, let's try one more question on this. Second question is, okay, so now we have a definite integration question. So basically we have a lower limit and upper limit. Lower limit is 0, upper limit is 1. Integration is x e power x. Okay, so when I see x e power x, the first thing that comes to my mind is it's a product of two functions and we have to integrate. So I have to use by parts. So let's just quickly write integration of u dv is equal to uv minus integration. See, it helps me once you start writing this 3, 4, 5, 6 times, you will remember this, and after that you won't even have to write this. You can directly solve the question. So that's the use of this writing, this integration by parts again and again for practice before exams. Okay, so then I will write what is my u, what is my v. Now if I use I late, algebraic I have exponential. So algebraic comes first. So obviously u is my x and my dv is nothing but e power x. If I have u, so du by dx, or simply I write du in short. So this is 1, and integration of dv will give me v. Actually it's dv by dx. So anyways, no problem. So v will come out to be e power x, integration remains same, so it's same. Okay, so once I have this, let's substitute the values. So u into v, so u is x, v is e power x minus integration. Okay, one more thing. Now this is not an indefinite integration, this is a definite one. So what you have to do in this, now be very careful in this, see very carefully. So first I write uv, then I will write the limits. So what are my limits? 0 to 1. So you always have to substitute the limits. Minus, then integration, limits are same, 0 to 1. Du into v, du is 1, v is e power x dx. This is my integration. So now I have to substitute the limit. So when x is 1, this becomes e power 1 minus, when x is 0, So this becomes 0. Okay. Minus integration of e power x. Integration of e power x is e power x. So minus e power x, and the limits are from 0 to 1. So let's solve this. So this becomes e minus, what is this value? When x is 1, so this becomes e power 1 minus e power 0. And e power 0 we know is 1. So this becomes e minus e plus 1. So my answer for this question is 1 only. So this is my answer. Now be very careful. I am telling you this because students, lot of times I have seen that they forget these limits. Okay. So substitute the limits here only. Okay. So this is definite question. Now we have done one indefinite, one definite. Now let's see one very important question. Integration of ln x dx. Now this is a very special case. Now you all might be thinking, this is one function only. Why do we need by parts for this? See, this can be integrated by other methods also. But what is in our curriculum is basic substitution, trigonometric substitution, and by parts. So this can be done by parts. So this is very important. Now first thing that comes to our mind is this is only one function. How can we integrate this? What is u? What is dv? Now what we do in this is, there are a couple of questions like this. So we might take some more questions in the next coming videos. So integration of ln x we can write as 1 into ln x. Obviously it won't make any difference. So now we have sort of two functions. Now obviously our formula is integration of u dv equals uv minus integration duv. So obviously the function u has to be ln x here. Why? Because we need the integration of dv to find the value of v, right? And if we don't know the value of ln x integration, so that's why it can't be dv. So the logical choice, obvious choice is we have to take this as u. And we know the integration of 1. So this can be taken as dv. So one very simple logical point, why ln x is u? Because if ln x is dv, then integration of ln x we don't know. That is actually we are trying to find out. Okay, so u is ln x, dv is 1. So du is actually du by dx. So differentiation of ln x is 1 over x. And integration of 1. So integration of 1 is nothing but x. Now be careful. I have seen some students making this mistake. What's the mistake? When they are finding v, they write constant of integration here. You don't have to write constant of integration here. Okay? There is no need to write. Even if you write, I mean, it's not a big problem, but you are unnecessarily writing it. So there is no need to write constant of integration when you are finding v from dv. Okay, that's another thing. So let's use the formula. The formula says this is equal to u, that is ln x, into v is x, minus integration of du into v. So du is 1 over x, v is x dx. Now you can see we can cancel this x. So this is coming out to be x ln x minus, now this is 1 only. So integration of 1 dx, that is x only. So minus x plus c. Now this is our final integration. So we will use some constant of integration. So this is our answer. As you can see, very easy. So integration of ln x is x ln x minus x plus c. So this is one of the special cases in which only one function is there. Even some trigonometric inverse functions are there. And if you have to find the integration of them, then you have to assume 1. So we will take these special cases in some other video. I hope you understand these three cases. So now we have done one indefinite question, one definite question, and one question in which only one function is there. Now in the next video, what we will do is we will see integration by parts in which you have to apply integration by parts at least twice. Yes, there are questions in which you have to apply integration by parts more than once. So we will see that in the next coming video. So one example is integration of e power x sin x. So in this we have to apply integration by parts twice to get the final answer. So we will see that in the next video. Thanks for watching.